Hello, everyone. Thank you for joining us today. We are really excited to be hosting this webinar on migrating your on-premise Hadoop to Amazon EMR. I am Devang Pandya, Managing Director here at TEKsystems Global Services, and primarily responsible for driving our customers' data modernization journey. I am equally excited here to announce that Roy Hassan from AWS also joined us together to present this webinar and talk around TCO and cost savings that Amazon EMR will bring to our customers. So super excited, guys. Thanks for your time today, and we will get going right into the agenda of today's webinar. Primarily today, we are going to focus on two main areas. First and foremost, we will go ahead and get started with what exactly Amazon EMR is. So we will give an overview of EMR, we'll talk about the benefits of it, and then we will talk why EMR is so important in any organization's data modernization journey. So we will go next in talking about the design patterns and how you can do the migration of your on-prem Hadoop stack into Amazon EMR, followed by TCOs, cost savings, and obviously the case study where we have seen tremendous value customers migrating their workloads on Amazon EMR. Before I go ahead and begin, I wanted to just point out that if any point in time, if anybody has a question, we welcome that. You will see a Q&A box or a window on bottom right corner of your screen. Please feel free to put any questions there, and we have a couple of other solution architects and leaders joining along with me and Roy. We will be happy to answer any of your questions that you may have. We will also have a Q&A time towards the later part of the presentation, but we absolutely encourage you, if you have any questions, please feel free to chime in, right? Last but not least, before I go into the conversation itself, at the end of the webinar, there will be a brief 1-minute survey. We really appreciate if you can take a moment and fill that survey. That would definitely help us, in serving you better in future. All right, so just a quick overview on TEKsystems. We are an industry leader in full stack technology services, talent services, and real world application, working with over 6,000 plus amazing customers, including 80% of them Fortune 500, all over North America, Europe, and Asia. Definitely very excited to be here today. And the reason I'm saying that one more time, because we have helped many of our customers in modernizing their data journey, working with progressive leaders like you, and basically drive change. So that's how we take it as a TEKsystems from our side. Now, when we talk about our AWS credentials, as you can see, we are AWS Advanced Consulting Partner, as well as we are preferred EMR migration partner. We provide full spectrum of service offerings in AWS initiatives across multiple key pillars, such as you can see here, cloud enablement, DevOps, or even modernizing your application or database modernization journey for building, cloud-first platform in AWS, if you will. Not only that, we can help our customers in implementing the AI and machine learning and bot automation on cloud platform as well. Now, the way we handle this entire thing from our side is, as you can see, from all the way beginning from strategy to design to migration to implementation, and obviously to adoption, which is the key piece, right? Adoption. So we have worked with so many other customers, as I have been mentioning earlier, and we are happy to, help out on enabling that cloud journey whenever, our customer wants. So without further ado, I'm going to just go deep right into the topic of Amazon EMR. And first, I will take a moment and briefly explain what Amazon EMR is. In a very, very simple word, if I may, Amazon EMR, it's a managed cluster platform, leading big data cloud platform, I would say. More importantly, it's a managed service offered by AWS to allow you to process and analyze vast amount of your organization's big data needs. And the main thing that I would emphasize here that EMR really simplifies running your big data workload, supporting through multiple frameworks such as Apache Hadoop or Apache Spark, Hive, or Presto, right? In fact, EMR actually supports total 21 big data frameworks, just to name few more, let's say HBase and Hudi and others. So really great offering in terms of managed services where you don't need to really install those complex Hadoop clusters, set up the network, add storage. It really simplifies it in many ways. Now, let's do a little bit of a fast forward, and I want to talk about how does EMR work in your organization leveraging data lake. It's a very simple 4-step process I would emphasize here. First and foremost, store your data into Amazon S3. As we know, S3 provides 11 nines of durability and virtually infinite scalability as well, right? So absolutely leverage S3 as your data storage. Once your data exists in S3 or data lake, you can go to step number 2, which is basically start configuring your EMR cluster. And when I say start configuring your EMR cluster, it's just a console. You need to pick what types of nodes that you want to select, number of nodes, as well as whether you are picking spot instances or instance fleet. All of those you can decide. And then you are also going to select the Hadoop application. So which EMR version you are going to use, starting from all the way from 4.0, which is long back now, going all the way to latest 6.0 and plus, right? So depending upon which AWS region you are, you may see different EMR versions available in the region, right? So pick your EMR version, and then you can spin up your EMR cluster in 2 ways. One is a cluster mode, where obviously EMR gives all Hadoop package applications installed based on your choice of selection. Okay, select this version for Hive or this version for Uzi and so forth, right? The other option to configure your cluster is the step execution mode. That means you can select, okay, I want to just spin up a, let's say, Presto application, or I may want to just spin up a Spark application, and then you can select what version and everything, and then obviously you can spin up that specific Hadoop application. Once it processes, the difference between cluster and step execution will start, and once the job completes, it automatically terminates. That's why it is very, very important. As I said, step number 1, always keep your data in S3 because that is the persistent layer, right? Once your cluster is configured, step number 3, obviously you want to launch your jobs using either EMR console or APIs or maybe through CLI. And then your EMR cluster is going to process that large amount of data, and then that output of processing data you can again put back into S3. So step number 4, consume your results from S3, as obviously S3 is a global service. You can access that data within AWS for any other services as well. Not only that, I really wanted to emphasize one more thing here as part of the EMR and data lake architecture standpoint. It supports many other analytical types and storage layers. So for example, you can have Redshift for your analytical workload where EMR can push the data to S3 that can go into, let's say, Redshift and RDS and DynamoDB and Kinesis, right? So very solid integration capabilities that you can leverage through that architecture. Obviously, one more thing, security, right? Very, very foundation requirements on any cloud project, with AWS providing that, either IIM or you can say data lake formation now, which heavily integrates with Amazon EMR. So that will always be available to capitalize in setting the right security controls and mechanics, etc. So why EMR? What I'm going to walk you through today is some of the challenges that we have seen in on-prem Hadoop environment. Obviously, Hadoop started probably good 10, 15 years ago, primarily on-prem, great concept of distributed parallel processing for, basically analyzing that large and variety of data, basically, right? Absolutely great offering. However, soon it became very cumbersome and time-consuming to manage those infrastructure and complex architecture, as I was talking earlier about setting up those clusters, networks, storage. More importantly, if you want to bring scalability, you have to pretty much plan that right size of Hadoop environment from day one. Either you end up being oversized or maybe you end up being undersized, and then auto scalability is obviously not available. You need to manually pretty much manage that. So what that all makes it very, very hard is operational efficiency, or, basically maintaining those clusters require a dedicated operational team, if you will. In many customers, we have seen that, right? The other significant challenge that we have observed in Hadoop environment is even if you are in off-peak hours, you are in always on mode, right? There is no scalability, as I was saying earlier. More importantly, even during the peak hours, let's say, if I may give an example, we are working with one of the healthcare customers where they have obviously multiple divisions within the organization, and everybody is sharing that one monster production Hadoop environment or a cluster, right? And they have to literally assign the resources by percentage that, okay, finance, you will get 20%, but marketing, you will only get 2%, right? And that creates a resource contention in processing the data and maintaining the SLA, right? So very, very critical thing to be aware about. Another drawback is the architecture of Hadoop, which is very tightly coupled for storage and compute. So let's say if you just need to add more storage, you are actually enforced to add one more node in your cluster, which also involves the compute power. So you are not just paying for the storage, but you are also unnecessarily paying for high compute costs, right? That's also make it a little bit harder, in scaling, as I was making a topic earlier, right? So all of these challenges are really, really painful in actually managing the entire Hadoop infrastructure and operationalize it, right? Now, fast forward on Amazon EMR, right? Why it is significant to go for any organization, in my opinion, for their big data processing for Amazon EMR. I have highlighted top 5 benefits that we have seen in multiple customer implementation. First and foremost, which is decoupling of compute and storage. So as I was talking earlier in the EMR slide, we have S3 as a storage, and you can add whatever the type of node that you want, whether it's a compute heavy or network optimized or memory optimized, right? you can scale them independently. S3 is virtually infinite scalable. That brings a lot of advantage in processing the big data workload, if you will. Second, being completely managed services, you can run either persistent or transient cluster deployment in your environment, right? Our recommendation is go as much as possible transient cluster. So in EMR architecture, if you go a little bit detailed, right? So you have a master node, then you have a core node, and then you have a task node. Recommendation is to go for spot instances as much as possible for the task node, right? And that will bring a lot of cost efficiency and etc. So try to be leveraging the transient cluster as much as possible and where it makes sense, right? But if you have to have a 24/7 always on, yes, we can have a persistent capabilities as well. Another prominent feature AWS recently added on Amazon EMR offering is built-in auto-scaling. So auto-scaling, there are two options. One is this manage auto-scaling feature that just came, and the other one is a classic auto-scaling. So in a classic auto-scaling, you will define rules and policies. Let's say you are going to have the cluster metrics monitored, and you can go up and down in the increments of 5 minutes. But with managed auto-scaling, it's in seconds. So it can be within 5 seconds. It always monitor your cluster metrics and auto-scale or go down based on the need of the workload, right? So elasticity is amazing with auto-scaling, right? Now, all of this benefits actually passing a lot of cost savings to our customers. And there is a journey to that, right? And when I talk about the migration approach, there are few architecture things that we need to consider. It's not just a lift and shift, and then you are going to start seeing the TCO when you migrate your workload. And Roy is going to talk about that, how that should be approached and things like that. So with that, let's go ahead and talk about migration journey, design patterns. How do you migrate your data? How do you migrate your processes? All of those things I want to walk you through. So at the TEKsystems, we have this proven methodology to migrate your on-prem Hadoop environment into AWS. We have successfully implemented this at many of our customers. And if you look at it, it's a simple 5-step approach. The first one is define. So before I start migrating any of my legacy applications or environment, I need to make sure that I do have a thorough profiling and assessment of that environment, right? So for example, in case of Hadoop, we highly recommend that you capture some of the key cluster metrics. So for example, what is the aggregated CPU count you have in your current Hadoop cluster? What's the memory size? Also, how much is the storage space you are using without replication of the data? Because as you know, HDFS, by default, the factor of 3 in terms of the replication to provide that durability. But when you migrate to AWS, you don't need to store your data 3 times because S3 itself provides that durability much, much higher, right? So we need to gather those statistics, and the way we can help out, as you can see on the screen here, TEKsystems has built some accelerators. For example, here AmpGS, that's our branding, Cloud Migration Toolkit, right? So we can come and analyze your Hadoop environment and gather those statistics so we can actually plan a better strategy from the migration standpoint. One more thing that we do as part of that is typically gather this statistics over the period of few weeks in order to get the pattern analysis. That it's not just a 1 week where I saw an immense utilization of the CPU and everything, but you need to kind of, average it out over last few weeks in order to really size your EMR starting point. And obviously you will go auto scale, so you don't need to worry too much about that, but important topic to have. Now, if I go to the next step, which is design, right? So there are 3 ways in terms of designing the strategy for the migration. One, you can do lift and shift. Second, you can do re-architect, or the third one could be hybrid. So let's say if you are running a very mission critical workload, we recommend that do a lift and shift, get it up and running in the cloud, and then start optimizing that workload and see how you can capitalize the TCO savings and all of those by leveraging auto scaling features and such, right? But usually just doing always lift and shift doesn't really make sense, right? But we need to really evaluate what kind of workload you are running, and based on that, the strategy can be defined and the architecture blueprint can be proposed in that design phase. Now, the step number 3 and 4, which is move data and move process, is absolutely critical. Yes, EMR is very easy to use, as I was explaining earlier, but when it comes to the migration, you need to plan it out. Very much thorough planning is required, right? And I'm not making any excuses here. It is definitely require a good amount of planning and strategy. So if I talk about the data, right? Obviously, you might be storing a lot of data into your HDFS. And even when I come and talk about moving the data, we can consider that from 2 steps perspective, whether it's a one-time data migration or whether it is also an ongoing data migration, which I'm going to further talk about what that data migration design pattern looks like, right? But AWS natively supports quite a bit of options. So let's say, for example, for petabyte and exabyte of data migration, you can use Snowball or even Snowmobile, if you will, right? And pump that data into S3. For ongoing, obviously you can use Direct Connect, which is over a VPN, right? Or you can do, file transfer using data sync. There are so many options available there, right? So that's just migrating the core data of your Hadoop environment. Then also comes the metadata. Typically, each and every Hadoop environment stores that metadata in Hive Metastore, right? Now, that's also important to get migrated along with your data. There are a couple of options there, and we will talk a little bit detail in few slides down the road. You can either take advantage of AWS managed services such as Glue Data Catalog or RDS, or even you can put that into Aurora database, right? Now, when it comes to moving the data, perhaps moving the data is not really that complicated, in my opinion, right? But where it is really important is when you migrate the data, how can you validate that everything is tying as it's supposed to, right? So that's where our test automation framework, which is another accelerator we can bring onto the table to ensure that not only your just one-time data migration, but even ongoing data migration, right, validates that data authenticity, if you will, between source and target. Once that move data step is over, obviously you need to take care of moving your processes. So as I was talking earlier, in Hadoop, you may have multiple applications, right, such as Spark applications or maybe Presto and whatnot. Now, not all the application will just be lift and shift and work as is. There are some fundamental differences, which I'm also going to talk during the lesson learned from our customer experience, right? For example, S3 is great durable storage, but it is not a file system, right? It is more an object store versus HDFS is more a file system, right? So there are nuances that we need to take care. When you migrate your processes, you might need to tweak some code and things like that. Along with move processes, the key element is your orchestration tool also needs to be migrated. So let's say most of customers either are using probably Uzi, or maybe some are even using Airflow. There are options available, but that orchestration job is free. If you are interested, that can also be migrated, as well as all your jobs or Uzi jobs can also be migrated, as part of the move processes. Then, obviously, last but not least, we need to really thoroughly plan the production parallel run and cut over. What we always tell our customers, start conservatively, right? Pick your non-critical workload and start there, do a little bit of a POC, make sure that everything is working before you start, rushing towards migrating all your Hadoop environment from on-prem to cloud. That typically works very well in the organization. Now, once all these 4 steps are completed, optimize so you can start leveraging some of those cloud native features to make things, better. And that's an iterative process. Okay, so let's briefly talk about the design pattern for moving the data. As I was talking earlier, you may have your databases on-prem. In your Hadoop environment, maybe you are probably pumping that data through either a replication or scoop jobs, or maybe write some custom scripts. In AWS, as you can see, there are multiple options available. AWS Snowball for moving the large on-prem data to cloud, even storage gateway, data sync, even data migration. So there are 2 things I mentioned earlier: one-time data load and ongoing data load. One time, obviously, you can use Snowball or whatever the means, direct connect, for example, right, to move it here. Ongoing, you can also leverage data migration services, DMS, which is also, because your database still can be on-prem, possibly, right? And you need to make sure that once you start decommissioning your on-prem Hadoop, how you are going to bring that data on ongoing basis into data lake, right? So that's where the DMS will come into a play. Then this example shows leveraging AWS Glue as a managed service. So you can write Glue jobs, basically ETL jobs, which can get the data through your DMS, put it into S3, right? Or actually DMS puts into S3, then Glue job can fix it up. Automatically Glue captures all that metadata of your schema definition, table definition in Glue catalog, right? And that is shareable across many other AWS services. So great feature to have when you are using, Glue data catalog in your architecture. Okay. Now, let's briefly also talk about the migration of your metadata, right? So typically in your Hadoop environment, let's say you are using a Hive Metastore, you can be either using MySQL Server or maybe even, embedded Derby database, right? And this is your Hadoop cluster on the right-hand side. In terms of the migration perspective, we recommend that if you are using MySQL, just migrate that into Oracle RDS, MySQL version, if you will. If you are using Postgres, obviously go to Postgres RDS version or even Aurora. Or, as I was talking about, you can even leverage the Glue catalog, right? Now, if you are sticking with RDS, let's make sure that you are enabling the replication, async replication, because many times Hadoop Metastore or Hive Metastore can be a single point of failure. And if you are going through RDS, you need to set up that replication in a different AZ and things like that, asynchronous. If you are using Glue, you are covered because it's a managed services, right? And then obviously this Hadoop cluster can be migrated to EMR. So that design pattern works very well from the metadata migration perspective. So high level, as you know, there are many components in Hadoop architecture, right? So we put together a quick snapshot. Let's say if you are using commercial Hadoop distributions such as Cloudera or Houghton or MapR, how would you handle migrating each of those functionalities? So let's say if you are using HDFS as a data storage, which is obviously the default in Hadoop, you can consider S3 as an equivalent offering. There are also other things I'm going to briefly highlight as part of EMR. There is a EMR FS, which provides the integration capabilities to S3, as well as for any reason you need to run your workload using HDFS, that option is still available. So you can leverage EMR file system as well as part of it. right? Part of the EMR cluster. Then I'm not going to go through each and every application, but this gives a good summary of, what are the equivalent services you can pick. So let's say, for example, you are using NiFi and Kafka from the streaming perspective. AWS offers MSK, which is Managed Service Kafka, or even Kinesis, right? So I think that's a good summary to keep it handy if you want. Really helpful. Now, this is a reference architecture we put together for one of our customers, and that's the case study I am also going to talk later today in the slide deck. There are two sections in this architecture that I wanted to highlight. The first one, if you see here, this can be your ongoing data migration, if you will, and what you are seeing at the bottom could be your one-time data migration. And then I have correlated, what equivalent AWS services you will use. So I'm going to start here. So let's say you have, one-time HDFS data that you need to migrate. We talked about, S3. Yes, load the data into S3, either leverage Glue catalog, which is obviously preferred managed service to use, or we talked about other options as well, right? RDS and such for metadata perspective, right? Then let's say you are migrating your Hive Metastore. This is important to note, right? So if you're migrating your Hive Metastore, we have seen customers preferring two options. Some customers say, I'm going to migrate everything to the cloud, right? So move my Hive Metastore into the cloud. Some say, okay, I want to do a one-time Hive Metastore migration, but I also want to have a sync copy on-prem, right? You can absolutely do that using AWS database migration services, right? So that is the service that you will use if that is the use case in your architecture. Or you can go with, Scoop and other scripting options to pump the data, either ongoing from your databases into AWS Cloud, okay? Then you can spin up multiple Amazon EMR clusters. So one of the examples that I gave earlier is, resource contention. Here you don't need to worry about. So your data science team can spin up EMR cluster for training their machine learning models, or your analytical team can kick off another EMR cluster processing high queries, or maybe, Presto and things like that, right? Even I would highly recommend consider Athena where it makes sense, right? Another managed service. If you are just querying data using standard SQL, it probably makes a lot more sense to leverage Athena. Last but not least, I'm showing here some Amazon EC2 instance. So by default, EMR doesn't provide all of those Hadoop applications. So let's say, for example, NiFi, right? You are using Hortonworks and you have a NiFi as a data ingestion pipeline. NiFi is not part of EMR, right? But you can still create that functionality. So spin up another EC2 instance and set up your NiFi through Bootstrap, and it will work just fine, right? So important to know that. And I briefly talked about, integration with lake formation and the security. So all those will be absolutely part of the reference architecture. And on right-hand side, you are seeing just the consumption tools, whether it's a Power BI, Tableau from your analytical footprint perspective. So with that, I'm going to hand it over to Roy to walk us through on the TCO.
Thank you, Devang. I hope I'm coming out clearly, my audio. Let's talk about some TCO. Why would you move your applications, your infrastructure to the cloud, including your big data infrastructure? One of the reasons, just one of the reasons, there are many reasons to move to the cloud, but one of the reasons is TCO, total cost of ownership. Is it going to be cheaper for me, right? So that's the question that our customers ask constantly to us. So in the next set of slides, what I would like to do is just kind of portray why it is cheaper to move your workloads your big data workloads, your Hadoop workloads from on-prem to AWS. So in this slide, I have a handful of slides here, and I'm going to pass this back to Devang. So in this slide, what I'm trying to tell you is when you think about a workload migration, you want to move a set of systems, your Hadoop systems to AWS. You're not just simply migrating that system. There are other infrastructure items that your workload will depend on. So it's not just a particular service such as EMR. It is all the other services that need to be part of your workload. Okay. And in this slide, what I'm trying to tell you is we have probably one of the most richest set of services when it comes to our capabilities on the cloud. Okay. So you see on the left-hand side and the right-hand side, I'm not going to go through all of those things, but it's data warehousing, storage, streaming, Elasticsearch, machine learning services, BI and analytics, NoSQL databases, many serverless solutions in this. So we have a wide variety of capabilities when it comes to migrating your workloads. But the star of our show today is EMR. So that's in the middle. Okay. And I have 3 points that I would like to cover. Number one, when you are migrating your workload, right? Chances are that at some level, as part of your migration, you may or may not realize this, but you are probably building a data lake. Okay. That may not be your intention, but once you start putting your data on S3, which is our recommended way, and Devang has at length has mentioned that you would want to, reduce the footprint of HDFS and move your data to S3. So as you do that, you are in fact building a data lake. When you are building a data lake, you would want to make edits to your data lake, and that's when Hoodie comes into picture. I don't know, if you guys are researching Hoodie or not, but Hoodie is part of our deliverables projects that we support on top of EMR. And Hoodie has become quite instrumental these days in the development of modern data lake architectures because Hoodie allows you to make edits, upserts to your data lake. Okay, that's number one. Second, Livy. Again, I don't know if this is a technology that, if you're researching, but a Livy endpoint will allow you to bring various different kinds of notebooks and attach those notebooks to an EMR cluster so you get an interactive experience. It's not just about running jobs. It's not just about saying, hey, EMR, run this job for me. How are you going to develop the script of the job? You need interactive capabilities. And as we support Livy, you will get to do that quite easily. Number 3, so Spark. Spark is a very popular platform on EMR. It just is a popular technology all around these days. But the open source Spark is one thing, all right? But open source Spark doesn't perform as awesomely as you would want it to. And therefore, what we have done is we have baked in a whole bunch of optimizations, optimized runtimes for Spark inside EMR, and all of these things are free. You don't pay for them. Okay, we spent years developing optimizations. So when you run Spark on EMR, you will be running Spark a lot faster than any other place, any other distribution that's out there. All right. And if something is fast, it means it's also cheap. Okay. So next slide, Devang, please. Okay. Now, you don't have to take my word for it. Why would you? And what I'm gonna do is I'm gonna just bring up at least 3 of the analyst groups that talk about our services. Starting with IDC, and I'm gonna just read them out. And if you have subscriptions to these these papers, definitely look them up and read them through them. Chances are you already, most of these papers are available publicly, including AWS. So in 2018, IDC confirmed that EMR provides 50% reduced costs versus on-premise, resulting in 342% ROI over 5 years. 342%. That's just an insane amount of cost savings that you can have by moving to EMR. Next, Gartner in 2018. AWS remains the largest Hadoop provider in terms of both revenue and user base. We have been doing this for a long time. EMR is one of our really old services. So we've been doing this for a long time, and we've been doing better than anyone else that's out there. Okay, so there is a ton of experience in running big data workloads on AWS. Forrester, 2019. We are a market leader, and if you can zoom in and look at where we are, look at the market share, and look at where we are in the Forrester chart, you will see very easily that we are not only a leader, we also have a pretty big market share, and we've been doing this for quite some time. Next slide, Devang, please. Again, you don't have to take the analyst word for it either. These are some of the quotes from some of our big customers. We got thousands of customers using our services. FINRA, a financial services company, cost savings by moving their on-prem Hadoop system to EMR is over 60%. That's $20 million. Vanguard decreased costs by $600K in 5 months. Now, this is something that's kind of interesting because I work with Vanguard, and they are way past the 600K mark because they continued to optimize their EMR clusters. So just this 600K in 5 months is what they were able to accomplish given a very short period of time. Airbnb, I love this quote because it's not so much about, hey, it's just cheaper to run on AWS. It was cheaper for them because we were 3x faster. Again, if we are fast, then we are cheap. AOL said we were both cheap and almost 60% more efficient. Guardian. Now this is something, I'm sure we got a lot of technical folks here, and you're here because you probably have a Hadoop system. The workloads on cloud are fundamentally different when you compare it to on-prem. In on-prem world, you are more likely to have 1 or 2 golden clusters, and these clusters run 24/7, and these clusters are shared by multiple teams. It's a multi-tenant cluster is what you would probably have on-prem. On AWS, those rules don't apply. You don't need to have a golden cluster. If you don't want to build a multi-tenant cluster, you don't have to. In many cases, these clusters are transient. It takes just a few minutes to spin up a cluster, run the set of workloads that you need to run, and shut it down. Okay, so in many cases, our customers have many sets of clusters, and not everyone runs perpetually running clusters. And that's a big cost saving when you compare on-prem Hadoop systems to EMR. Next slide, please, Devang. All right, a couple more slides, and I'm going to pass this back to Devang. Most scalable and cost-effective data platform per second billing. If you run your EMR cluster for 15 minutes and 31 seconds, that's exactly what you pay for. Not a penny more. But if that's not good enough, you can pre-buy certain compute. We call them reserved instances, okay, RIs. If you can say that I see myself running EMR few hours at any given point in time, so how about you pre-purchase those compute resources and therefore get massive savings. That's a reserved instance. Spot. I will just have you guys research Spot. Spot is you bidding on resources that are unused. If you can run EMR on Spot instances, resources that are just idling, you can bid for those resources and get those resources for 80% cheap. Okay, huge cost savings. No one can really beat that. S3 versus HDFS. As we all know, HDFS is a three-way replication. With guess what? With S3, we have taken care of data replication for you. So you copy data once, and we will make sure that it is secure and also reliable. Managed resize, and Devon touched upon this, managed resize. So if you are going to have a cluster, how big of a cluster are you going to have? It's very hard to sometimes to kind of pinpoint exactly how big of a cluster you're going to have. How about you get to specify the minimum set of nodes in your cluster and the maximum set of nodes in your cluster, and we will resize that for you. We released this some time back, okay, and the kind of response that we have received from our customers is incredible. So we will automatically resize the cluster based on the workloads that you're running, and we will add and remove nodes, but we will stay in the range that you want us to be, which is minimum and maximum number of nodes in the cluster. Okay. Again, that will save you money. EMR runtime for Spark. I briefly mentioned that. Open source Spark is one thing. How about a company that has invested years in optimizing Spark runtime on EMR? We run fast, the fastest Spark on AWS, on EMR than anywhere else. And that optimization is free for you. Something that would take an hour to run elsewhere will probably finish many minutes earlier, and therefore you save money. Capacity aware spot scaling. Now, this is for the folks that are a little bit, more in tune with the spot market. What this means is you get to pick and choose the instance sizes as part of your EMR fleet. What we have done is we have built so many optimizations that when you lose an instance, you're right, because of the way spot market works, and we replace that instance with a different instance, we have built so many algorithms to make sure that when you get an instance, you keep that instance for a long period of time. So we are more likely to give you an instance that we have a lot of, and therefore you get to keep it for a longer time, and therefore less disruptions. And again, all of these things are included to you at $0. This is something that we take up on ourselves to make sure that you have the best EMR runtime than anywhere else in the market. Next slide, please, Devang. Finally, hey, I'm not going to just tell you this, that you take your on-prem Hadoop system, you move it to AWS as is, and boom, you have all the cost savings. No. We will still be cheaper, but that's just me telling you. But you know what? It may not be significantly cheaper. Lift and shift may not be significantly cheaper. You're going to have to optimize this. So our recommendation, as AWS and TEKsystems, is that if you are to do a lift and shift, don't kill yourself on how much cheaper it's going to be. Okay, just move it to AWS and then optimize over a period of time. Remember, Vanguard, 600K savings in 5 months. Okay, which means they move it, lift and shift, and then you start optimizing by instance right sizing, S3 versus HDFS, transient clusters, managed scaling. Maybe you will use Spot, and a whole bunch of automation that we have built so you can save money when you bring your workloads to AWS. Do I have another slide, Devang? I think I'm done with TCO.
Yeah. No, thank you, Roy. Really appreciate you giving us the insights. And I can definitely vouch for what some of those benefits that you talked about, Roy. Customer has sometimes, misconception that if I go with Spot, I'm going to lose that instance at any moment. But very recently, if I'm not making mistake, I think AWS released some article where they were showing that availability of Spot instance was over 99% or somewhere there around. So you guys are good to go and leverage the Spot and put that savings in your organization's pocket. Absolutely no doubt. Okay, so I think I'm going to quickly talk about the best practices. During the entire presentation, we talked about quite a bit of this stuff. So I'm not going to repeat those things. I'm just going to highlight two key ones here. So though we are talking about EMR primarily on this one, as I was talking earlier, do not just restrict yourself for only EMR. There are some other integrated services available from AWS. Let's say if you want to use Glue for Spark processing, or even Redshift for analytics, or Athena, consider them when it makes sense, right? Last but not least, if you look at it on the right bottom corner here, this is really important to know: file size and file format. So as we know, Hadoop has typically a block size of 128 MB. We highly recommend that you keep your file size closer to the block size. Don't deal with too many small files. Combine them or group by them into a one large file. I think it's a lot better in terms of the processing and etc. Another thing that we definitely recommend, leveraging the columnar file format instead of just the CSV or plain text files. Go with Parquet or even EORC, depending upon your needs. It really adds up in the performance. And as Roy mentioned, faster means cheaper in AWS terminology. Okay, so here are some of the key lessons learned from customer implementation. I think we talked a lot about, try to leverage Spot instances, at least for your task node. Very, very important. Second thing is Bootstrap, which I briefly touched upon earlier, to automate your cluster upon provisioning. Now, there are a couple of use cases I would highlight. Let's say within a 1 hour, if you are running 3 workloads, 15 minutes each, I wouldn't say that, okay, you shut down and restart your transient cluster. It will be hard, right? Because it will take a few minutes to spin up the server. I would recommend in that case, you keep your master, and if you keep bare minimum core up and running, but rest all your task nodes, use the Spot instances that you can terminate, right? And when your 15-minute workload is over, just shut it down and then wait for the another 5 minutes or whatever the gap, or 10 minutes, and then spin it up, right? Really, really important to know. The other thing is, which is crucial, I think sometimes probably development team or IT organization, or even some unfamiliarity, if I will, right? So HDFS is a POSIX compliant file system API, right? So let's say if you rename the file, it's instantaneous atomic operation. But if you are putting your data in S3 as we recommended, it's a block storage, right? So need to be careful in leveraging rename and seek and some of those APIs. You might need to tweak your code a little bit. One way to get around that is EMR-FS consistent view. You can enable that if you are doing a lot of dependent reads from one job to the another. Always enable that EMR-FS consistent view, really helpful, right? And as we talked many times, auto scaling is amazing, so leverage the power of built-in managed auto scaling in AWS. I already spoke about the reference architecture of this customer. It's a large high-tech manufacturing organization. The use cases, they were running the Hortonworks Hadoop on-prem. Now, as I was talking earlier, first and foremost thing is when we engage in any customer project, first thing we do is the migration readiness assessment, right? So during that EMR migration workshop, we looked at their existing environment, and we discovered that though they have 50-node Hadoop clusters, they are in fact not really utilizing that much compute power. They just needed to add those nodes just to store the data, right? So that's the one key metric we identified right away, right? And then when we migrated them gradually from on-prem to EMR, we were able to do that data storage, which is, as Roy was mentioning, almost 1/3 of the cost compared to HDFS, 67%, 2/3, right? And we established that storage migration, and as you can see here, we got pretty much same amount of cost savings right off the gate, right? When we migrated from on-prem Hadoop to EMR. Obviously, we leverage our accelerators to expedite the journey of the migration and reduce the risk of implementation during the entire process. Very, very powerful, successful story from the migration standpoint, and obviously they are global, leveraging all the global infrastructure of AWS in processing their big data workload. Last thing before I pause, I know we are running against the time now. How can we jumpstart, right? So TEKsystems provide a free AWS EMR migration workshop. Please contact us, visit our page, and we are more than happy to help out. Obviously, we partner with AWS in many of those initiatives together as an advanced consulting partner. So allowed to help you guys out. Now, one quick question I would ask, how many of you are using on-prem Hadoop today? Please feel free to put that response in Q&A or chat, whatever works for best. And before we close, I'm going to pause for a few minutes and see if any questions from the audience. Some options are coming in the chat. Let me just make sure I'm able to handle this. Yeah, in terms of the orchestration tool, you can obviously have Oozie, or you can go Airflow also. You can also consider AWS Step Functions, which is again a managed service and really integrated with many other AWS services. So those are the 3 or 4 well-known options. AWS Step Functions is the serverless. Oozie kind of give you, the same look and feel, if you will. One thing I would say though, Oozie UI is not exactly available in EMR. You may need to use U from that Oozie UI perspective from the monitoring standpoint. So I just wanted to highlight that part. Any other questions, team? Yeah, also, just I'm not too sure whether how many of customers will have this situation, but we definitely encountered this in a few of our implementation. So moving the data between HDFS and S3, as I talked about, a few options out there, right? But recommended path is leverage S3 distributed copy command, really helpful to leverage that functionality for the bulk data movement. If you also, there are some open source options available. This API is by default available in EMR, as I was talking earlier. But there are some commercial options also available. Let's say if you are using Cloudera, then Cloudera BDR can also help you move your HDFS data into S3. So I just wanted to share some of those tips as well. Few other things. If you are considering to use EMR 5.8 or later, then you will have the Glue data catalog available, but prior version Glue data catalog is not supported. The other best practices or tips, if I may add, if you are using Impala by any chance in your workload today, EMR does not have Impala application installed by default, but as I was showing in my reference architecture, you can spin it up through Bootstrap and let it run in standalone EC2 instance as part of your cluster. So definitely solutions are available, but I just wanted to share some of those nuances that we have seen in customer implementation. So we are right at the top of the hour, team. I can hang on. If anybody has any questions, please feel free to type it in Q&A box or chat, and we are happy to clarify. Otherwise, thank you, everyone. Just take a moment, please, to fill out that survey once we end this webinar. We really appreciate your feedback. As I said, I'm going to hang on for maybe a minute or two, just in case if anybody has any questions. Thank you, Ramesh. No problem. You're welcome. All right. I think I'm going to stop sharing and conclude this webinar. Thanks, everyone, for joining. Again, thank you, Roy, as well, for giving that insight from the TCO standpoint. And we look forward to hear back from you, either through survey or reach out to us for free EMR migration workshop. Thank you, everyone, and have a great rest of your day. Bye.